Welcome to the future of heavy-duty transport. What you see here represents a revolution in how we move goods across the globe. By integrating advanced hydrogen fuel cell technology into a traditional semi-truck framework, we are achieving the ultimate goal of long-haul logistics. A vehicle that produces zero emissions without compromising on power or performance. At the heart of this innovation is the hydrogen fuel cell system. This isn't just a concept, it's a sophisticated engineering feat. By replacing a traditional internal combustion engine with a silent, efficient fuel cell, we transform a heavy polluter into a clean energy machine, capable of tackling the most demanding routes while leaving nothing behind. Storage is a critical piece of the puzzle. High-capacity, reinforced tanks are strategically integrated to hold compressed hydrogen. These systems are designed for maximum safety and density, ensuring that enough fuel is on board to match the range of traditional diesel trucks, which is essential for the practical needs of the trucking industry. Inside the fuel cell unit, the real magic happens. It's a complex arrangement of plates and membranes where chemical energy is converted directly into electrical energy. This process is continuous and highly efficient. As long as hydrogen and air are supplied, this system will generate the electricity needed to drive the massive wheels of the truck. Efficiency is maximized by the layout of the chassis. Large cylindrical tanks store the fuel while the fuel cell stack serves as the onboard power plant. This modular approach allows for better weight distribution and durability, ensuring that the technology can withstand the rigors of thousands of miles on the open road. The chemistry involved is remarkably simple yet powerful. Hydrogen enters the system, oxygen is pulled from the ambient air, and through a controlled reaction, electricity is produced. The only byproduct of this entire process is pure water. It is a closed loop of clean energy that redefines what environmentally friendly means for logistics. To understand how we get power from gas, we look at the internal architecture of the fuel cell stack. It consists of three primary sections: the anode, the membrane, and the cathode. Each plays a specific role in splitting hydrogen atoms and capturing their energy, creating a reliable stream of power for the vehicle's propulsion. Slide 8 focuses on the movement of particles. Hydrogen enters the anode side where it is stripped of its electrons. These electrons are forced through an external circuit, creating the electricity we need. Meanwhile, the remaining protons pass through a specialized membrane to complete the reaction on the other side. Once electricity is generated, it must be put to work. This power is sent directly to a high-torque electric motor. Unlike diesel engines, electric motors provide instant power and incredible efficiency. This transition from chemical energy to electrical energy and finally to mechanical motion is seamless and highly responsive. The journey of energy follows four clear steps. First, hydrogen is stored safely. Second, it is processed in the fuel cell stack. Third, the resulting electricity powers the motor. Finally, that mechanical power is delivered to the wheels. It is a streamlined process designed for the demands of heavy-duty hauling. Slide 11 illustrates the environmental impact of this technology. By removing the carbon-heavy combustion process, we eliminate greenhouse gas emissions. The internal components work in harmony to ensure that every molecule of hydrogen is utilized effectively, providing a sustainable alternative to fossil fuels in the transportation sector. The benefits are clear and numerous. Beyond having water as the only emission and achieving zero carbon output, this technology offers fast refueling, comparable to diesel, and a long driving range. These trucks are reliable, durable, and operate much more quietly, improving the environment for both drivers and the communities they pass through. When we look at the big picture, hydrogen represents a sustainable future. It improves air quality, reduces noise pollution, and fits perfectly into existing long-haul operations. It is a technology built for demanding conditions, providing the performance of a traditional truck with the heart of a clean energy solution. The microscopic interactions within the cell are what make this possible. We track the flow of ions and electrons as they move through various layers. This electrochemical reaction is what generates the current. When this technology is applied to a semi-trailer, it results in a powerful electric propulsion system that feels like the future. By separating positive and negative charges, we create a flow of energy. This generated electricity is transferred via heavy-duty cabling to the vehicle's drive system. The result is a truck that moves with the silence and precision of an electric vehicle, but with the range and refueling speed required for the shipping industry. On slide 16, we see the basic progression of the energy cycle. It starts with the introduction of the fuel and ends with the output of work. Each step is carefully managed by onboard computers to ensure maximum efficiency and safety, regardless of the load the truck is carrying or the terrain it faces. Oxygen from the air and hydrogen from the tanks meet in a specialized reaction zone. As they interact, the energy released is captured as electricity. This power then flows through the chassis to the motors. It is a beautiful example of how clean chemistry can solve the massive problem of industrial carbon emissions. As hydrogen molecules interact with the membrane, electrons are released to form a current. This electricity is what drives the truck forward. By harnessing this flow, we eliminate the need for heavy batteries, allowing for more cargo capacity while still maintaining a completely green footprint on the environment. The beauty of this system is its simplicity in output. While traditional engines emit a cocktail of pollutants, the fuel cell simply produces water vapor. This makes the truck a mobile air purifier of sorts, taking in oxygen and releasing clean water, all while performing the heavy lifting of modern commerce. Protons pass through the membrane while electrons take the long way around through the motor. They eventually reunite with oxygen to form water. This cycle is the foundation of the hydrogen economy, providing a way to store and use renewable energy in a form that is practical for heavy-duty trucking. Slide 21 represents the microscopic dance of particles that powers the entire vehicle. These reactions happen millions of times per second across the surface of the fuel cells, providing the consistent and reliable power needed to maintain highway speeds and climb steep grades with a full trailer. The movement of the electron is just one part of the narrative. The story of hydrogen power is about the entire life cycle of energy, from how it is sourced to how it eventually returns to the environment as a water. It is a continuous, sustainable loop that supports a healthier planet. As we look at the opposite side of the fuel cell, we see that air is constantly being drawn in. This air provides the necessary oxygen for the reaction. The integration of air intake and hydrogen flow is a precise balance, managed to ensure the fuel cell operates at its peak efficiency. The oxygen within the air is the final ingredient. As it passes through the porous materials of the cell, it meets the hydrogen ions that have traveled through the membrane. This meeting creates the electrical potential that we tap into to run the truck's various electrical and mechanical systems. Millions of oxygen molecules move toward the reaction zone every second. This constant influx of air is vital. The design of the truck ensures that even at high speeds, the fuel cell receives a steady supply of oxygen, allowing for sustained high-performance output during long-haul trips across the country. When the oxygen molecules arrive at the catalyst surface, they are ready to bond. This catalyst is a critical component, as it lowers the energy required for the reaction to occur, making the fuel cell incredibly efficient at converting chemical potential into usable electricity for the vehicle. At the same time, the protons from the hydrogen arrive at the same catalyst surface. They have traveled through the internal membrane, and their arrival signifies the final stage of the electrochemical process. This synchronization is what allows the system to produce a steady, reliable flow of power. 3 separate paths meet here: electrons from the external circuit, protons through the membrane, and oxygen from the air. When these 3 elements converge at the catalyst, the reaction is completed. It is a perfectly choreographed event that results in the power we need and the water we release. This convergence point is where the reaction happens. It is the core of the technology. By managing these 3 paths, electrons, protons, and oxygen, we can control the amount of power being generated, allowing the truck to accelerate, cruise, or climb with ease and precision. In this view, we see the entire system working together. Hydrogen and oxygen enter, electricity is harvested to light our way and move our loads, and water is the harmless byproduct. It is an elegant solution to a complex problem, providing a clear path forward for sustainable transport. The internal layers of the fuel cell are composed of specialized, porous materials. These layers are designed to maximize the surface area where the reaction takes place. The more surface area available, the more electricity we can generate, which is why the internal structure of these cells is so intricate. As hydrogen molecules split, they release the energy we need. This atomic-level interaction is the primary source of power. By understanding and harnessing this splitting process, we have created a power plant that is more efficient than any internal combustion engine ever designed for a truck. Slide 33 highlights the active electrochemical process. The blue glow represents the energy being released as protons move through the central membrane. This movement is the pulse of the vehicle, providing the vital energy that is then converted into the motion of the wheels. The movement of water molecules away from the reaction zone is just as important as the fuel coming in. Efficiently removing the byproduct ensures that the reaction can continue without interruption. This ensures the truck can run for hours on end without any drop in performance or efficiency. Ultimately, this is how we generate electricity from the most abundant element in the universe. By combining hydrogen with oxygen, we tap into a clean, renewable resource that can power our world. It is a sophisticated process that results in a very simple and clean outcome. The energy generated doesn't just sit there, it flows. We see these energy trails as a stream of charged particles moving rapidly. This flow is what carries the power from the fuel cell stack to the motors and the onboard electronics, keeping everything running smoothly. This energy transfer is a dynamic process. High-tech conduits and circuit boards manage the flow, ensuring that power goes exactly where it is needed most. Whether it's for high-speed cruising or heavy lifting, the system adjusts in real time to provide the optimal amount of electricity. A power management system acts as the brain of the vehicle. It monitors the circuitry, manages the battery buffers, and directs the electricity to the motors. This complex network ensures that the truck operates safely and efficiently under all driving conditions, from freezing cold to desert heat. The internal components, like copper coils and processors, work together to convert and regulate the electricity. This allows the truck to use the power generated by the fuel cell in the most effective way possible, minimizing waste and maximizing the range of every tank of hydrogen. The connection between the control unit and the motor is the final link in the power chain. Vibrant energy strands carry the instructions and the electricity that tell the motor how fast to spin. This high-speed communication is what makes electric trucks so responsive and easy to drive. Inside the motor, we see the interaction of magnetic fields. When electricity flows through the copper windings, it creates a powerful magnetic force. This force is what pushes the rotor around, turning electrical energy into the mechanical torque that moves the entire truck and its trailer. The operational dynamics of the motor are truly impressive. By using magnetic fields instead of explosions, we gain much more control over the vehicle's movement. This results in smoother acceleration, better traction control, and a significant reduction in the wear and tear of mechanical parts. This high-tech engineering allows for a motor that is both compact and incredibly powerful. The blue lines of energy illustrate how we can achieve massive amounts of torque without the bulk and complexity of a traditional transmission, leading to a more reliable and efficient drivetrain. The process at the wheel follows a logical sequence. Electricity comes in, a magnetic field is formed, the rotor turns, and torque is delivered. This direct delivery of power means that the truck responds instantly to the driver's input, providing a superior driving experience and better safety. Finally, that torque makes the wheels turn. It is the culmination of the entire process we've discussed. From a tank of hydrogen to a rotating wheel, every step has been optimized for efficiency and environmental responsibility. This is how we move the world without hurting it. The entire powertrain is a network of energy pathways. From the power control units to the rear axles, every component is integrated into a cohesive system. This advanced technology ensures that energy transfer is as efficient as possible, losing very little power to heat or friction. Power transmission in an electric truck is a feat of modern engineering. By focusing on the flow of electricity and the efficiency of the motor, we can provide heavy-duty transport that is both powerful and clean. It's a complete rethink of how a drivetrain should function in the 21st century. When the truck is in motion, all these systems work in harmony. The fuel cell provides the power, the motor provides the torque, and the control systems manage the flow. The result is a sleek, modern vehicle that can haul heavy loads across the highway with ease and zero emissions. This transparent view shows us the heart of the machine. The hydrogen tanks, the radiator, and the motor all work together. It's a clean, quiet, and efficient way to handle the world's shipping needs, proving that we don't have to choose between a strong economy and a healthy planet. In conclusion, the journey from a simple hydrogen molecule to a moving semi-truck is a testament to human ingenuity. By harnessing the power of the most basic elements, we are driving the future of clean transportation. This is the zero-emission reality, and it is ready to hit the road.